a national competition with this project. But the truth is, it was a complete trash. Here's how it was when I took it to the nationals. You can see there is a total chaos. Everything is just hot glued and broken. On top of it, you can see here a GPS module. Only two wires are going out of it, but to actually use it, you need at least four wires. It was here for show off and nothing else. So, how did I win a national award with this garbage? I won because of two things. The first is the core vision of this project, and the second, my presentation and public speaking skills. I told the judges that this rover was capable of helping the military. It could stream live video feeds to your screen. It can be used to rescue and research missions where humanly entrance is not possible or equivalent to losing their life. Was it capable of all it back then? Not even close. I faked it till I made it. I relied heavily on my speaking skills and realized that it was not fair for other competitors. Even though I won national level, but I was not satisfied. I knew what was under the hood, and I wanted to make something real, something that I could actually be proud of. This time, no faking it. We are building a system with real capabilities of a true tactical spy, research, and rescue rover, including an airborne drone, long RF signals, and including a custom communication protocol. Every success and every failure and every step of build will be documented here in the series. As I build Trinetra, I am maintaining an open source GitHub repository where you will find all the codes, schematic, circuit diagrams, and useful resources about this build. In fact, the previous codes that won the national of Trinetra version 1 are already live on the page. Check out the GitHub link in description and drop a comment with what you want to be included in this project. And if you want to contribute and follow along, subscribe this channel and I will see you in the next episode.